going to talk about a few things with regards to functions. Number one, we're going to talk about just basic definitions. And actually, I'm going to leave you to write that out. You just say, what is a function, right? It has an input and an output value. Not everything that looks like a function in terms of equations is a function, right? There's a test that we use to determine if something is a function. And that test is called the vertical line test, okay? So that's the first thing to know, is there's a way to identify what a function is, right? This is more of a quadratic function. So we have quadratic functions, we have linear functions, we have exponential functions, we have logarithmic functions. There's different types of functions. So number one is knowing your basic definitions. Number two is playing around with when we say f of x is equal to something, how does that work in finding the output value? So we're going to talk about that. Number three, we're going to talk about inverse of functions and composition of functions. So inverse and composition of functions. Number four, we're going to talk about operations involving functions. And let's see, we're going to be reminded here quickly that there is the domain and the range of functions. And the domain deals with the x values, the range deals with the y values of the functions that we're dealing with here. Okay, so those are some big topics to hit. There's trigonometric functions, which we'll discuss more in our pre-calculus class preparation. But let's dive in to number two. F of x is equal to x squared plus 5. If someone says, what is f of 2? What that means is that you substitute the value of 2 in for everywhere you see x. So that becomes 2 squared plus 5. So in this case, it just becomes 4 plus 5, which is 9. This is the input, and that is the output. So the output is 9. When x is 2, y essentially is 9. So now you say, where did we get y from? When I write f of x there, I could also write it in that form. I could write it like that as well. Since we're on this topic of input and output values, you should have learned how to graph, and you should be comfortable with then using these values, right? So when x is 2, y is 9. So you go to a graph, and you go to where there's 2, and then you go up to where there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and you put it over there. That's the point that you found. And if I said, well, what about when x is 3? So then you put in y is equal to 3 squared plus 5. What about when x is 1? You put in y is equal to 1 squared plus 5, and so on and so forth. So that's the idea, is that you have an input value and an output value, and then you transfer it to a graph, and believe it or not, that graph will look something like that. How do I know that? Because this is x squared plus 5, which means that the default graph of x squared was taken and moved up 5 spaces. Now that is another topic called graph transformations, but it's just there's a way to do math quicker if you remember some other topics. However, if you don't remember that topic, just plug in x values here, like 0, 1, 2, -1, -2, and it'll give you the different values to plot, and then just connect them, and it creates a parabola, which is a quadratic function. Okay, so that's number 2. There's an input value, and you plug in that value of x in here, and that will give you an output value. Number 3, let's talk a little bit about composition of functions and inverse of functions. So composition of functions is basically when I ask, what about if someone says f of g of x? If f of x is equal to x plus 5, and g of x is equal to x squared plus 6, then the composition of functions is, instead of plugging in the value of x that I was talking about before, these two things are the same. Whether I call it f of g of x, or if I say f of the g of x now representing x. Okay, let's take a step back. Over here, notice it's just f of x is equal to x plus 5. But what if I change this x here to g of x? What if g of x is now the input value? That means this whole thing is now the input value for x. So instead of f of x is equal to x plus 5, I'm going to say f of g of x, which means I'm going to take this value and say basically f of x squared plus 6. That whole thing is now going to represent x in my f of x. So it becomes, instead of x plus 5, right, it becomes x squared plus 6. This whole thing is like the x that was originally here, and then plus 5. And then I basically just add like terms. So that becomes x squared plus 11. So f of g of x is equal to x squared plus 11. We took the g of x and substituted it in for the f of x value. That's what composition of functions is all about. And we have like 20 problems of this if we want to practice. So Tyler Wallace, chapter 10, or if you're using our full Tools for Mastery Math program, it'll be like down past quadratics. Right after quadratics, you get into some of this stuff right here. Okay, again, this is a quick review. I'll come back and answer questions, and we'll go from there. Inverse of functions. Now, keep in mind in a traditional school, you would learn this for like a day or two. So this is really fast forward mode. Inverse of functions, you will also learn for like a day or two. But the idea of inverse of functions is if someone says, what is the inverse function of x plus 7? There is a systematic way to do this. And you have to remember the steps. The first step is to write this in the form of that. So you have to get comfortable with when we go from f of x and just write y. It's very easy just to know that that's something we do. The guy who came up with this again is my guy, Leonard Euler. He's the one who came up with this idea of writing f of x. Okay? So Leonard Euler came up with like 90 things in mathematics. And there's a reason why he's one of the most prolific. So instead of f of x is equal to x plus 7, you write y is equal to x plus 7. That's step 1. Step 2, so we've done step 1. Step 2 is switch your y to x and your x to y. Switch all the x's to y and all the y's to x's. So this will become x is equal to y plus 7. Step 3 is solve for the new y that you now have. So basically this will become y is equal to x minus 7 because we subtract 7 from both sides. This is the inverse of that. If you were to graph these, you will notice that they have a relationship. Inverse functions have a relationship between the original function and the thing that is called its inverse. One relationship that you might notice is their table of values even. So if you have a Desmos calculator, I want to encourage you, or just any calculator, try plugging in the original function and then try the inverse function. It's amazing to see. So we're going to take a break and pause, reflect, and then we'll finish out number 4 and 5.